This is video number 3 for one sample mean tests. This time we're going to look at a word problem and do a full example. When checking marketing claims by certain food retailers in Canada, we check actual weights versus claimed weights. As an example, bags of sugar that are supposed to weigh 5 kilograms may deviate. So we take a simple random sample of 36 bags from which we get a sample mean of 4.9 kilograms and a standard deviation of the sample mean is 0.33 kilograms. What we're asking is this evidence of underweight bags of sugar? We're going to use a significance level of 0.01 to test this hypothesis. So the first thing we're going to do is identify the null and alternative hypotheses. The null is always that there's no real difference, no change. So we'll set mu equal to 5. Now we're asking about, is this evidence of underweight bags of sugar? So that suggests that the alternative is that the mean weight is actually less than 5. Significance level is 1%. So that's what we'll set alpha to. This is a one-tail test because of the less than symbol, so we'll just take the raw p-value from the t-table when we get there. Now, what's our values here? This is the claim, and that is mu. Our random sample is 36, so that is our n. The sample mean is 4.9, so that's y bar. And the sample standard deviation is s, 0.33. Those are all the pizzas we need, so let's write this out. We need y bar minus mu over s over square root n. Degrees of freedom here, again, is n minus 1, so that'll be 35. Plugging in the numbers, we have 4.9 minus 5.0. This is 0.33, and we'll take the square root of 36. So if you do the math on your calculator, this is negative 1.818. That's our test statistic. Now, let's go to the t-table and see what that produces for a p-value. So here's row 35, and 1.818 lies between these two values. So as far as the p-value goes, we must go to the top of the page. Our p-value is less than 5% and greater than 2.5%. I'm going to come back to this notation in just a moment. I want to expand on that, but let's finish our problem first. Well, with our p-value less than 0.05 and greater than 0.025, this interval is entirely greater than the 1% level of significance. So while there is evidence of underweight bags, it's not significant. So we have to fail to reject the null hypothesis. In context, we can say we did not find evidence of significant underweight bags of sugar at the 1% level of significance. Now let's go back to the t-table for a moment. I want to point something out. Oftentimes, test statistic values are either very small when compared to the values inside the table like these, or they're very large. Well, you'll notice the trend at the top. P-values are very big over here. So any test statistic that is greater than the values in this column are going to produce p-values that are either bigger than 20% or bigger than 10%, depending on if it's one-tail or a two-tail probability. If the test statistic is very large, then the p-values will be over here, and they are small. either smaller than 1% or smaller than 0.5%. Either way, we end up with rejecting the null hypothesis. And this is how we're going to handle any of the t-test values that appear in this course. If the test statistic is very small, then that means we fail to reject. If the test statistic is very large, we're going to reject the null hypothesis. And we'll see that through some more examples coming up.